Hello everyone, my name is Sumit Kumar and I am an undergraduate student from BIT Meshra. Our paper named as Biomedical Network Link Prediction using Neural Network Graph Embedding. This paper is part of CODES COMAD 2021 ACM India Joint International Conference on Data Science and Management of Data. This paper is co-authored with Rajratan Pranesh and Ambesh Shekhar. Now we'll see the outline of this presentation. So we'll begin with a brief introduction. We'll see the motivation behind the paper, then data set. We'll explore methods and experiments we did. We'll see the results and we'll discuss and finally conclude the paper. So the introduction, why graph embedding? Since graphs are used worldwide to represent biomedical nodes and edges, also the success of neural network models in various domains leads to predicting potential drug. And it has the ability to automatically learn low dimension feature representation for different nodes. And while learning low dimension feature, it has the ability to retain the structured representations also of the graph, which acts as a feature for link prediction task. So the motivation behind the paper. The property of graph embedding learning to automatically learn low dimension node representations attracted a lot of researchers, and lack of analysis of biomedical data using latest graph embedding methods also attracted a lot of researchers. Hence, it is very crucial for a systematic analysis on biomedical data using latest neural network based methods. Now the data set. For experiments, we choose three common biomedical data set from different biomedical databases. The first data set is ND-FRT-DDA, second one is Drug Bank DDI, and the third one is String PPI. And these were used for different link prediction tasks. Now, ND-FRT-DDA is used for drug disease association prediction. Drug Bank DDI is used for drug-drug interaction classification, while String PPI is used for protein-protein interaction classification. Now here's the proposed model. So we proposed three models and all three models were based on neural network model. First one is line. Line is used to directly models the node embedding vectors. SGNE based model uses a deep autoencoder to preserve the second order proximity by reconstructing the neighborhood structures of each node. And the third one is GAE. It uses a GCN encoder, which is a variation autoencoder, and variation autoencoder is used to generate new graphs. Now methods and experiments. So we performed our experiments on three compiled biomedical dataset, and we already discussed these dataset in the previous slides. So DDA prediction is done using TMF, temporal link prediction techniques, in which a DDA matrix is factorized to learn low dimension representation of drugs and disease in latent space. So the primary challenge of TMF is to capture the spatial temporal patterns and high non-linearity of dynamic networks. We use OpenNE, which is an open source Python package for network embeddings. It is used to learn node embeddings for line and SDNE. We used SVD, singular value decomposition using NumPy to obtain embeddings for GAE method. And let's see the data set training and test part. So the data was split into training set of 80% and test set of 20%. Also, the number of unknown links are greater than the known ones. Therefore, we randomly chose broken edges as negatively, we chose broken edges as negative with an equal number of positive samples in both the training and testing stage. For every node pair, We concatenate the embeddings of two nodes as edge feature and made a logistic regression binary classifier using sklearn package. And this classifier we are used to classify and predict the links of different data sets using different proposed methods. So as you can see, the result, uh, as you can see, methods are in vertical, and the horizontal, we have three data sets. Uh, Now, discussion. As seen in table 1, GAE method performs better than the rest of the models in link prediction task over drug bank DDI and Spring PPI dataset. As you can see, GAE methods outperformed the other methods in both drug bank DDI and String PPI. In drug bank DDI, it achieves 91.7% of accuracy, and in String PPI dataset, it achieves 89.9% of accuracy. Although line performed better on ND-FRT DDA dataset, so as we can see, ND line performed yes better on ND-FRT dataset. It actually performs 96%. And since both methods are based on neural network graph embedding models, therefore it deserves greater attention for future biomedical link prediction and analysis tasks. In future, we want to further increase our data set in order to conduct extensive experiments. So if given a larger data set, we can get better results and get more insights using the neural network based models. So I want to end the presentation. Thank you.